Welcome back to the CAD/CAM design tutorial. Today we are going to learn our previous 26 component assembly in this video. First of all, we make all components of our Sprocket concept model. Now in this video we make assembly and one animation of our Sprocket model. Now first of all, going to this new and this assembly. Now in assembly, default folder is open, but we cancel it and cancel. Now all options are shown in this slide. Most of insert component are widely used. Now first of all, our object image is look like this, means total 26 component part. And see, the animation of our today exercise is like this. Now first of all, insert our first component shaft. Then going to all our object are this 1 to 26. First of all, open shaft and just drag like your cursor, drag like this. Now our shaft is default placed. Now going to one more time insert component and insert our second component, bearing. Now see, this our second component is bearing, and in this bearing we also draw, means design a part, means inner ring, outer ring, or ball bearing or ball, or we make one assembly. Now we use this assembly to make our video is time consuming less. Now first of all, one bearing are inserted, and one more time insert one more bearing. We need number of bearing is 2. Now going to mat, and this both bearing, sorry, edge nahi, this both bearing shaft is make it concentric automatically. Okay, now this bearing ID and this shaft OD make it concentric. Now one more time, bearing rotational motion are done, up down are locked, and left and right motion are performed. We locked this motion, then going to this face and this face. Okay, now same as this face and this face, bearing motion are locked. Now see, the bearing are rotate, but not in linear or upward or downward direction, only rotate. Now insert our next component. First of all, these 3 parts are there. Now insert our next component, part number 3. Part number 3 is Sprocket hub. Then is look like this. Now first of all, open and see, this is our object, means part number 3, Sprocket main hub. Now going to mat, going to this mat selection and select this shaft surface and select this face, make it concentric automatically. Now this up down motion are lock, left right are perform, and rotational are perform, means on. In actual condition, this shaft hole and this hole are make it concentric, but in this video or in this tutorial, if we make this both hole are concentric, then our rotational motion are lock. Now we once perform, select this and select this, both are concentric, but our this Sprocket hub is not rotate, only bearing are rotate. different way are there. Lock this two and rotate this one. Now bearing are locked. Now this concentric means second concentric we delete, and see these are linear motion are performed. Now select this face and select this face, make it coincident. Now click OK. Now see, this hole are not concentric, then this is in rotating motion. Done. Now going to this our third part and hide this, not needing this time. Now first of all we insert our next component, insert, and going to part number 4, circlip, to lock bearing linear movement in actual condition, not in software. Now going to mat and select this face and select this face. Now both are concentric, or select this face and select this face. Now done. Now in software 2 or 3 way to copy our object or insert. Now first is insert and select this our part and open, and second one is first of all cancel it. Now second one option is select our component, press Ctrl and drag our object like this whenever we need. Now going to mat, select this face, clear it and select the concentric relation. Now our circlip are there. Now select this face, inside face, and select this face. OK, and select this face and select this face. Both are coincident. Now our circlip are perfectly placed, and in actual condition bearing are not linear movement are possible, only circular motion are possible. Now cancel it. Now this is our part, not need. Now insert our next component, part number 5, shaft pin. This pin use to this shaft, make it tight in with respect to axis or position, or first of all OK this one. Now we not need this shaft lock movement, this is in this relation are only. Now we lock in last. Now first of all insert this successfully. Now insert our next component, hub support. Now this one was done, but we need the main sprocket hub. Then we relation to this, both are relation. Now first of all show means see in the slide. Now going to mat, select this surface and select this surface. Both are concentric. Now this one was done, only linear movement are possible. Select this face and this face, make it coincident. Now same as this hole, when our object motion are locked, then in that condition also our object movement are locked. If we insert this circular hole and this circular hole, make it concentric, then our object is lock, then we now going to mat, select this lock, select this object and select this object, and okay. Now these both are locked perfectly and rotate same. See, now we insert the screw part number 7. Part number 7 is screw open and placed on this face. Going to mat, select this face and this face. Okay, now this face and this face, now both are in coincident. Okay, also select vertex or surface. Now this is not locked with our main object, then going to lock this face and this object. Okay, now see, this rotation are perfectly done, rotational movement are perfectly done. Now going to this assembly and make it in circular pattern, then going to this pattern and select circular pattern. Number of pattern is 6 and the face is this one. Any circular selected, but we select this circular. Now select this component is this. Now see, this our 6 screw pattern are there. Okay, now see, our the pattern are perfectly created, and see, these are in rotating position. Now insert our next component, part number 8, shaft sleeve. Open it in, okay, like this. Now next component is also sleeve or spacer, like this. Now first of all one cross section view to we learn better. Now going to mat, select this face and select this shaft, this face, make it concentric, and next one is this face and this face, make it coincident. Now our first sleeve is perfectly placed. Now going to this face and this face, make it concentric, means both center are same, and okay. Now linear motion are performed, then going to select this face and select this face, both are in coincident. Now see, only rotation motion are there. Okay, now this cross section off and one more time show. So this our two spacer and two sleeve are placed perfectly. Now going to close this. Now insert our next component, part number 10, spacer, disc brake supporting spacer. Now this is our spacer to between our disc brake and this sprocket support. Going to mat, select this face, concentric. Now this face and this face, make it coincident. Now our this spacer are perfectly done, means placed Now insert our next component, part number 10, second side sleeve. Now going to this mat, select this face and this face, make it coincident, or another relation is this face and this face. Now this coincident relation delete. Now going to this upward side, drag our object like this, select this face, and this face, this face, make it coincident. Okay. Now our second side spacer is perfectly placed. Now okay. Now going to insert our next component, part number 12, this disc brake supporting plate, and okay. Our disc brake plate look like this. Going to mat. Now first of all select this face and this face, make it concentric. Make it concentric. Now if we apply the screw relation, then our object is only rotating once. Our object, one is fixed, one is rotate. Then we only apply this option. Now this object is perfectly placed and rotate in its axis. Now insert our next component, part number 13, bearing. Now this bearing is in this side and this both side. First of all make it cross section, then we learn some better our object. Now going to mat, select this face and select this face, both are concentric. Now select and this face, both are coincident. Okay. Now see, this our bearing is little bit foul in our object. Now okay, this change in our assembly. Then going to evaluate, measure, select this face, this one diameter 20, and our bearing, first of all clear this bearing. OD is bearing, OD is 20.96. Now change in our bearing, then going to our part number 13, open it in another. Now going to this first one, sketch and edit, and normal it. Now going to this smart dimension, select this face and this center line and this one. Now somehow diagonalist, okay. Now this equal length relation is extra, then erase it and okay. Now 20.96, this dimension is 19.900, done and exit it. Now this our bearing is modified and save it, exit. Then one and see, this our bearing is not foul in our this sprocket supporting hub, done. Now this bearing is perfectly placed. Now we insert our next component. First of all, close this cross section view. Now bearing are perfectly placed in this shaft. Now going to assembly, insert part number 14, disc brake disc. Now first of all, going to this mat, select this face and first make it concentric, and now select this face and select this face, make it coincident. Now same as this hole, if we apply the relation of concentric or coincident relation between this hole, then our object is lock. Now first of all we apply concentric, select this and select this edge, concentric, okay. Now this our object is not rotate, then going to this delete. Now both are done. Now one more time going to mat and select this lock, select this one and this supporting plate, both are in lock position. Then our object is locked and rotate perfectly. See, done. Now we insert our next component number 15, screw, means rivet type screw. Now drag like this. Now going to mat, select this face, make it concentric, this face and this face. Now somehow distance and okay. Now done and lock. First of all clear the selection and select this coincident, select this one and select this, make it coincident, okay. Now over this rivet or bolt are placed perfectly but not in lock position. Then going to select this lock, select our object, select this our plate, okay. Now this both are in lock and rotate perfectly. First of all cancel it. Now somehow our object rotation movement are lock. Now our assembly look like good. Then see over this object. Now first of all clear the selection, select this our rivet or bolt face, or select this face, make it concentric, and select this one, and this edge make it coincident, and okay. Now see this our object is rotate perfectly, rotating motion are there, achieve. Now okay, select this our object and select circular pattern. Now we need 6 number of rivet or circular pattern, and our shaft is this. Now show in the slide, this circular pattern are perfectly created. Now done. Now going to insert our next component, part number 16, circlip. To lock this spacer and this disc brake movement, going to mat, select this face and this face like this. Okay, now our linear movement of circlip are available. Then select this face and this face, make it coincident, and see this our disc brake spacer, disc brake supporting plate, all are in lock. Now we lock this shaft and this one, and going to insert our next component, part number 17, nut, look like this. Now first of all going to mat, select this face, make it concentric, done. Now select this nut, this face, and bearing this face, make it lock in shaft linear movement. Now see the nut are in rotating motion, but bearing is lock inner ring, and outer ring is rotating position. Now this shaft is also movable. Now first of all we now in last we lock this movement. Now we insert our next component, part number 18, nut or designer nut. Select this face and this our shaft pin, this face, make it coincident. Okay, both are in coincident but not in concentric. Then select this face and this face, make it in concentric, and done. Now our object inside the our main assembly. Then we select this face and select this face, make it in relation. Now our object is not any movement, linear movement are there, only rotating movement are possible. Now our one side assembly is complete. Now we assemble our next side, all part and assembly. Now first of all okay, then going to insert and see our next component, component number 19. This is our oil or grease nut, is look like this. Now going to mat, select this face and this face, make centric, first of all hide this, and see this our object is here. Now unhide this, and see our one relation concentric are complete. Now we apply tangent relation to this face and this face, both are in tangent. Okay, now this nut are perfectly placed. Now we insert one more component, means one more grease nut or oil nut to make oil easily. This shaft mate and this face make it in reverse. Okay, now done. Concentric. Now going to mate, select this face and same as tangent and select this face. Done. Now our this grease nut or oil nut is perfectly placed. Now cancel it. Now going to insert and see our next component, part number 20, stud or sprocket stud or rivet. Now first of all make it in concentric, select this face and this face, concentric. Okay, now we make distance to this one and this one, and in lock position distance. Okay, now this part is perfectly inserted in lock in some distance. Now we make it circular pattern, this object. Now first of all select this object, this our full object, and circular face is anyone of the circular of our in assembly, and this our part means number of circular pattern entity is 6. And okay, and see this our object is perfectly number of pattern 6 are done. Now insert component and see our next component is 21 side sprocket support, but we need 2 bearing. Then our next component is part number 13 is placed on this face, means first of all now one more time we in this area we apply 2 bearing. Okay, now cross our object is like this, means apply cross section to in our object. Now this both are delete first of all. Now we insert our next component 21, this one open. Now first of all this one, then our object is show in the slide. Going to mate, select this face, go in centric, and this face and this face make it in coincident, but not in both circle are same. Now this one was done. First of all, okay this and lock this object and this object. Okay. Now if our object this one rotate, then this our sprocket hub is rotate. Now okay this one, going to cross section, okay, and now we insert our bearing, two bearing, part number 13. Select this one, open this, and one more time this, insert, and this. Now in cross section view, our object, inserted object is not show in the slide. Then one time this cross section hide, and one more time cross section on, then our object is show in the slide. Now first of all, going to mat, select this one and this one, make it in concentric. Okay. Now linear motion are performed to both bearing, then lock linear motion to both are coincident, means joint. Now only this concentric, this face and this face, make it in concentric, and now select this face and select this face, make it look like this, not foul. Our bearing dimension is decrease, and okay. Now one more time uncheck this cross section, and one more time cross sectional view, and okay. Then see our all part is show in the slide: stud, screw, spacer, disc brake, supporting plate, nut or hub, sprocket, bearing, shaft pin, or etc. Now we insert our next component. First of all this one. Now insert our next component, main sprocket. Main sprocket is look like this. Now going to this mat, select this face and select this, select this face and this face, make it in concentric. Okay. Now another relation is select this our sprocket, supporting hub, and this face, make it in coincident. If we apply the relation in our this both object, first of all uncheck this, means cancel. Now select this, going to mat and lock, select this object, select this one and this one again. Okay. Now if we rotate our this sprocket, then our this sprocket are rotate, means sprocketing hub is rotate, then our object is rotate, means our sprocket is rotate. Now insert our next component, means nut, to tight our object, this one is look like this. Now our nut is in not perfect position, then going to this rotate component and rotate like this. Done. Now going to mat and select this face and select this face, make it in concentric. Now drag this like this, select this face and select this face. Now our this object, means bearing are lock and our shaft is tight. Now we tight to full our sprocket. Then now we insert our next component, part number, first of all going to insert part number 23. Now going to this mat, this face and this inside face make it concentric, okay, and this face and this face make it coincident, and okay. Now see, our object is placed perfectly and used in like this. Now going to insert one more component, I think 24, yes, okay. Insert component, going to this 24 number 24 circlip to lock this sprocket linear movement in actual condition. Select this face, make it concentric, okay, and select this face. Now our the circlip are perfectly placed. Now only our circlip rotation movement are there. This one is random movement in our object. Now see, this our, if our sprocket hub rotate, means if our sprocket rotate, then our sprocket hub is also rotate. Now cancel it, insert our next component, part number 25, handle to tight our sprocket full mechanism. Now first of all rotate our object is like this, okay. Going to mat, select over this face, pin face, and this face, make it in concentric, and this face and this face make it in coincident. Now see, this our sprocket handle perfectly placed, tight and loose, tight and loose. Now going to insert our last component of this assembly, component number 26, pin or lock stud. Now select this and this, both are concentric, and select this face and this face, make it in coincident, and okay. Now our full assembly is done. Then first of all see the cross section view of our object. See, now see first of all the cross section view of our object. Is look like this. This is our assembly, all part, 26 part. And in this video, if we apply exploded view, then only going to this and explode our all view. Now Now our assembly is done. Then we going to go this motion study, and in this motion study we apply separate motor or another. Now we first of all, this one was rotating another, this one was rotate another. Now first of all select going to this model and going to this mat, select this one and this one, make it in lock. Okay, okay. Now this one lock to this. Now if we rotate this one, then our full assembly is rotated, shaft is steady. Now cancel it and see this our object is rotate. Now going to this motion study, going to this motor, rotary motor, component direction, select this one, reverse this one, and this RPM is 25 and okay. Now going to this calculate, now this last relation, this one and this one, make it delete, close. Now okay, going to this model, select this and this, both going to first of all mat, lock, okay. Now select this and this, lock, okay. Now going to motion study, this one rotary motor can delete. Going to this motor, select this one, okay. And play this video. And save it. Now save in our main object. This is our final assembly. Don't forget to like video, share this video with your friends, and do not forget subscribe channel for more tutorials. Thank you for watching video and give your valuable time to this video. And in my YouTube channel see another video, and thanks for watching video.